Okay, it's wow. Okay. Hello, everyone. So I am now here in Bali, so I cannot attend the class. Yeah. So through this video, I hope you guys find the clear discussion on the integrated science for physics topics. Okay, about the answers. All right. Now, shall we discuss starting from the okay? Question 51 is the first question in physics. Yeah. Okay, now let's discuss about this one by one. Let's jump into question number 51. I will enlarge this uh, the the PDF, yeah, so you can see it more clearly. Okay, question 51 is to tick the correct statements, yeah. The correct statements about sound and the vibrating object. So, this one, yeah, should be clear, yeah. The source of all sound is vibrating object, correct, yeah. Yeah, we don't talk about how rapid is the vibration. It's just that the source of all sound must be a vibrating object. So we need to checklist the first option. Second, sound wave travel fastest through a vacuum. Well, guys, we cannot hear the sound of the sun from the earth, right? Even though the sun possibly creates sound, yeah. So we cannot tick this because this is wrong. And then third, the vibration direction is the same as travel direction for sound wave. Sound wave, remember, is a like this, yeah, is a longitudinal wave in which the vibration direction, shows let's draw something like this, yeah. This is the direction of uh, let's say this is the direction of vibration, yeah, back and forth like that. And this is the direction of transfer, yeah. So it is correct, yeah. The vibration direction is the same as travel direction for sound wave, yeah, even though it is back and forth. The fourth, in the tin can telephone experiment, sound travels through the string because vibration from the first can are transferred by the particles of the string. That is correct, yeah. From one can to another can, this experiment, yeah, from one can to another can, it need to travel through the string. Okay, then in next question, tick one box showing the correct way of vibration travel through a string. A string, guys, yeah, a string cannot move back and forth. That's why moving up and down is the best for a string. Okay, so this is the answer, yeah. We need to tick the first option. Okay, and then the two boys are making a thread. Well, there could possibly some answers. Yeah, these are one of the three of many answers. Okay, first of all, the string need to be stretched. Correct. Remember the experiment, when you don't stretch the string, it doesn't work. And then the string is not blocked. Remember, when if you just touch the string, then the sound cannot travel. Yeah, it is blocked. And then the cups must be hard because if you change the sound already travel through the hard string, so it need to be arrived at the hard cup. Okay, if they replace the yarn with copper wire. Well, copper wire is more stiff, guys, yeah. So what will how will the sounds how will the sounds Buddhi hears, yeah. It will be better, it will be louder, it will be clearer. Well, whatever answer, as long as it is refer to these types of answer, it is correct. Now explain your reason. Because sound travel fastest through solid materials, yeah. The harder the material, the fastest is flow, it transfers. Okay, next, in question 54, okay, name one animal that uses echo to find object. Well, there are some, guys. You can say bats, you can mention whales. Yeah, some whales use echo. Okay, and then again, the military submarine and the military ship. Yeah, so the what we call the sonar goes down, yeah, and then it goes back up, reflected up, so that uh, how long the sonar move through water in a speed of 1500 meter per second. So by knowing the speed of the sound when it travels, then you guys can predict how long it takes. Okay, once you know how long it takes, you can determine the speed. All right. Now, in first question, calculate the distance that traveled by the sonar delivered from the ship until it arrives back. Well, remember again, it moved to the from the ship to the submarine, and then it reflected back to the ship. Yeah. So double the submarine found out to be 1,200 meters below the ship. It's the distance is below the ship, but the distance traveled by the sonar is go down 1,200 meters and then go back up 1,200 meters. So the total is 2,400 meters. Yeah. Now we find the time needed by the sonar. Since the speed is equal to distance over time, let's say then we just need to rearrange the equation. We got time is distance over speed. The time is oh yeah, the time is equal to the distance is 1,200 meters. The speed is 1,500 meters. Okay. Wait a minute. Okay, come on, guys. Let's think critically about this, yeah? So the time needed, find the time needed by the sonar to travel, yeah? The sonar travel is not 1,200 meters, okay? Be critical about this. So it travel again, like look at that, 2,400, yeah? 2,400 meters divided by 1,500 meters, okay? So the result is about, let's say, let's use the calculator. 2,400 divided by 1,500, it's 1.6. Okay, so the time it takes is 1.6 second. Okay, now let's go to question number 55. This is quite challenging, I know. Yeah. So this is the cone tip. In this case, the source of sound is at A, right? Um, what we need, so A is the source of the sound, yeah, and the distance between the two dotted lines called 1 unit distance. Reflector placed vertically somewhere around Z, yeah, somewhere around Z. So we make lines here. You guys can use a guiding lines like this one, like the red one, yeah. Let's say that's uh, uh, wherever it is around Z, yeah. So it's about there. Okay, 30 unit distance from the buzzer. The man uses a small cone, this cone, right? To hear the reflected sounds. Yeah. So remember, guys, again, remember that the angle of reflection, the angle of incoming, yeah, and reflection must be the same. Okay. Then try to create a line that can uh, try to create a line and its reflection the way the incoming sound and the reflected sound like this, it will go pass through the cone tip. Okay, this is how it looks. Okay, so that means you have to, if you see this one, yeah, here the black line here shows uh, the the position of the reflector. Draw lines to show the path of the sound when it travel from the buzzer. Yeah, the red line here, that's the sound. And then draw a line to show the position of the reflector. There you go, the black line. And the man assistant move the buzzer somewhere around Y. Okay, they move the buzzer now somewhere around Y so that the reflected sound is still clear. Okay, so that the reflected sound is still clear, that means we expect that the sound, the source of sound is around this line. Yeah, let's say the main assistant move the buzzer somewhere around Y. Okay, somewhere around Y, guys, that means it's about possibly here. Yeah, somewhere around Y, there you go. So we need to put the sound source around there, and then draw a dot and label it with B to show the position of the buzzer now. Okay, remember we need to make sure that the reflection still come to the cone tip, right? So let's make a dot here. Let's make a dot. Okay, let's say that's a dot. Okay, let's make it black. and label it with what? B. Okay, label it with B. There you go. Okay, now let's go to the next question. Well, this one is somehow you guys need to remember, yeah, the content of the book, yeah, about the inner core, the outer core, the mantle, the crust. Okay, the crust is possibly the easiest because it is the solid outer layer. Yeah, that's the easiest. While the tricky one is possibly this one. Yeah, the mantle is the molten rock below the crust. This is very clear. While be careful with this one, guys. Yeah, careful with the inner core and the outer core. You have to open your book and find out the this one, the structure of the earth. Yeah, there you go. This is the structure of the earth. So it says that here, yeah, in the center, it is made of metal, nickel, and iron. The outer part is outer part of the core is molten, while the inner part is solid. Okay, so that's why the inner goes to solid iron and nickel, and the outer core goes to molten iron and nickel. Okay, so that is our discussion. Oh, wait a minute, we still have some questions, yeah. So what causes the tectonic plates to move? Because of the flow beneath, yeah. It's the mantle that moving, yeah. It's the magma that's moving. That that's why the tectonic plates is moving. Okay, and then state what can happen when tectonic plates rub against each other. Then open your book again. Open your book. On that page you will find uh, yeah, on that page you will find, yeah, you'll find that when it rub against each other, then earthquake will happen. And then let's go here. Okay, this is the picture of the sun and the moon orbit, and this is the earth, right? Now we need to label first the penumbra with P and U with the umbra. Okay, there you go. This is wrong, guys. Okay. Okay, let's delete this, let's delete this, let's delete this one also. Okay, so where is umbra? Umbra is here with the area where it doesn't get the sunlight, while penumbra is here where it gains only a few of the sunlight, yeah, not totally blocked. Okay, and then we need to draw another circle showing so M here is the moon. We need to another circle to draw another circle representing the moon. But let's take a look. X is for uh, X is for the partial moon eclipse. Yeah, X is partial moon eclipse here. Some of it is in umbra where it's blocked from the sunlight. Some of it is in penumbra where it still gains some light. Yeah, so it's partial. Only a part of it experience eclipse. Okay. Next, the total moon eclipse. That means it need to be totally blocked from the sun. Yeah, it's here. Yeah, uh, exactly behind the Earth. Yeah, if we look from the sun, it is exactly behind the Earth. And last but not least, yeah, when it creates the solar eclipse, we need to label it with Z. If it creates solar eclipse, then it need to be in front of the Earth, yeah, between the sun and Earth. So here, this is the position. Okay, there you go. This will create what do we call it? Sun eclipse. Okay, okay. Good luck for the remedial, guys. Be sure to learn, and God bless you.